So I'm starting lecture 4 and let's start the camera. So in lecture 4, let's start uh, by understanding the concept of non-linearity in differential equation, which is mainly partial differential equation. The way you saw in ODE, like how do we decide equation is linear or non-linear. So there we saw that when two terms are being multiplied, differential coefficients are being multiplied, or like it's like y square, or like some main differential part is being multiplied. So like you know how to decide ODE. In same way in PDE, whenever you see p into p, that is p square, or p into q, p cube, or q into cube, q square, so these terms will make your PDE non-linear terms. And here I have written when you have p square or q square or something, because we have total 5 terms, right? P, Q, R, S, T. So usually our questions are based on P, Q only. So that's why we rarely go for R, S, and T. But it's all right. You will be having some questions where R, S, T, and R, and P, Q, R, S, T, everything may come. But those questions will be very, very lengthy. Okay. But if you see at GATE Aerospace perspective, so whatever I'm going to cover here, they will be the best way to cover PDE for GATE Aerospace. So when you have non-linear PDEs, in those non-linear PDEs, we don't have to cover first of all for GATE Aerospace. And when you will learn non-linear PDEs in your college days, university, then that time you'll be also learning Charpit's method. So Charpit's method also we are going to skip here. We don't have to cover here. Now we have to cover linear PDEs with constant coefficients in second order. So when you have a linear PDE but of second order, like just before this we covered a lecture Lagrange's linear ODEs, PDEs. Okay, Lagrange's linear PDEs. There we saw PP QQ is equal to R, right? So P and Q, they both were of order 1, but here we are seeing linear PDEs with order 2. So this type of PDEs, whenever we solve, we have to calculate our CF and PI for the complete solution. So CF means complementary function, PI means particular integral. Same thing we are doing in ODE also. So for this GATE Aerospace preparation, we will not discuss PI, we will discuss only CF. So PI you skip, and let's understand what kind of symbols we are going to use. Whenever you see dou by dou x, we will write that as capital D. Whenever you see dou by dou y, you will write D prime. And whenever you see something like this, dou 2 divide by dou x dou y, so first you split this as dou by dou x into dou by dou y. So dou by dou x you write as D, and dou by dou y you write as D prime. So you can see in the last one I have written DD prime, right? Now what are the steps? So to understand the step, you understand this fundamental first. What kind of equations you are going to get, because we are deciding two order. So order 2 means dou 2z, dou 2z, dou 2z will be coming, dou 3z, dou 4z will not be coming. But for practice purpose, I have given questions for dou 3 days also and dou 4z also, because they will add value in your PD preparation in GATE Aerospace exam itself. Okay, so steps you understand. Like what was the step in ODE? In ODE, whatever equation was given in ODE series, right? What was question was given, we used to calculate. First we used to take y common, and then we used to convert that auxiliary equation, then we used to find out roots, then based on nature of the roots, then we used to decide what would be our CF. Very similar fashion here also. In this equation we will take care z common, because z is a function of x and y here. So z common, so what will be remaining inside? Dou 2, you can see on the screen, dou 2 divided by dou x square. I mean a naught, a1, a2 is there as a coefficient, they are constant coefficients. A naught, a1, a2, they are not the function of x, y, z, they are just constant coefficients. They are some numbers, consider. A naught, a1, a2 you leave there as it is. You think on dou 2z by dou x square plus a1 dou 2z by dou x dou y plus a2 dou 2z by dou y square. Take z common. When you take z common, then whatever is remaining, there we'll be getting this form. Dou by dou x will become d, or dou 2 by dou x square will become d square. Dou by dou y will become d prime. If dou 2 by dou y square, then it will become d prime square. Like that we'll do here. So you can see when you take z common, the first term will become a naught into d square plus a1 dd prime plus a2 d prime square. Clear? Till here clear? Now here some very strange step you have to accept. To solve to find out complementary function CF of partial differential equation, after getting auxiliary equation of a naught d square plus a1 d prime plus a2 d prime square is equal to 0, you have to assume d is equal to m and d prime is equal to 1. So this d is equal to 1 m, what I am assuming here, d is equal to m and d prime is equal to 1. This assumption you will substitute in the same equation of a naught, a1, a2. So you can see here, this d is equal to m, I substituted here, so I got m square here. Then m here also like d, and d prime I substituted 1 and d prime I substituted 1. Done. So I got this equation. Now this equation is your auxiliary equation. Now in this equation you can see it is quadratic in m. So quadratic in m means what? You have to find out two roots in m. In my upcoming examples, I have given you examples for cubic also, for biquadratic also. So there will be having 3 roots, 4 roots. So you'll understand case 1. Case 1, what is the possibility? Suppose you don't have only 2 roots. Suppose you have m1, m2, m3, m4, lot of roots, and all roots are real and different. I'm mentioning real and different. In that case, what will you do? Complementary function, how do you write? You remember how were we writing in ODE? C1 e power m1x plus C2 e power m2x. So in the solution only x was coming, and right side what was there? Y is equal to C1 e power m1x plus C2 e power m2x. So m1, m2, m3 is appearing in the solution, right? Same thing here also, but here because z is the function of y and x both, so y and x both should appear right side. So, and of course it will convert into function because you are continuously seeing that function is coming. So f1 bracket y plus m1x, this term is coming because of m1 root, plus f2 y plus m2x, this term is coming because of m2 root, plus f3 y plus m3x. Like this you keep on going if you have more roots, and in this explanation you can see m1, m2, m3 all are different roots. Now case 2 roots are not equal, but here see case 3 I have considered like all the roots are equal, but in case 2 let's suppose m1 is equal to m2 but they are not equal to m3 is separate root. For example, m1 is equal to 1, m2 is equal to 1, m3 is equal to 2. So this kind of roots if you get, so of course this kind of root you'll be getting in cubic equation. So in that case how will you write your answer? You will write your answer like this. See m1 and m2 they are same, right? So m1 you write here and m2 also you replace with m1. Okay, what we did here, as it is we wrote only one extra x I multiplied here. It means from here to here I am giving effect, I am showing the effect that m1 m2 roots are equal. That's why m2 I replaced with m1 and I extra multiplied x. Same thing we saw in ODE also, we were multiplying extra x, right? You remember? Now the last term which is coming because of m3 I wrote as a separate term. Like in first case I am writing all the terms separately, so here for m3 I am writing separate term. Then you go for case 3. In case 3 if all the roots are same, then what will happen? f1 y plus m1x, this term is coming because of first root, f2 y plus m1x second root, but second root is also equal to m1, f3 y plus m1x, m3 is also equal to m1 because m1, m2, m3 they are all equal. But here what is extra? Multiply x here, multiply x here. This multiplication will tell you that okay all the roots are equal, right? So it's like here x power 1, here x power 2, and here x power 0. Anyway, don't go into that detail, just grab something what you're. After that we will see one example. So first example itself I have not taken quadratic equation, I have taken cubic equation because in cubic equation will be having more roots, so the concept will be much better. So first thing you take z common. You can see on my screen whatever I have explained here, I have taken this z common. After taking z common, whatever is remaining there only you have to replace d square, d cube, whatever is. So this term you will replace with d cube. Let me take this up. After taking z common, this term you will make as a d cube, and you can see here this term you will make as d square, and this bracket term d prime, and here again d, but here again d prime square. Okay, so now this became a cubic equation. Now I have taught you how to find out root of cubic equation in when I was teaching you ODE. So use that concept and you find out. Then you can see replace one thing. After getting d equation, you have to replace d equal to m and d prime is equal to 1. Then you will be getting equation in form of m, and this m will become your auxiliary equation. Find out root of that. So what was the trick there? You have three choice: 0, 1 and minus 1. Substitute any one of this 0, 1 or minus 1 in the equation. Then on 0 I got entire equation 0. It means 0 became my first root. If 0 became your first root, then remaining equations you can find out, right? With you can divide by x minus 0 and you can find out whatever is remaining. So that will be quadratic. In the quadratic you again split, you'll be getting two more roots. Just practice that, you'll be getting okay cubic equation roots. So okay, I got three roots, and you can see all the roots are not equal also. So here I will write f1 y plus 0 x, 0 is your m value, f2 y plus m, y plus 1x, this one is because of this thing, f3 y plus 3x. Okay, so three different functions I am writing here, and I am not multiplying x or x square anywhere because roots are different. Be careful. So then you multiply, I mean this 0x will become nothing, so only y is remaining here, 1x will become x, so x came here, and 3x, right? So final answer. Now we'll see this example. In my next example, dou 2z by dou x square minus 4 dou 2z by dou x dou y plus 4 dou 2z by dou y square is equal to 0. Again quickly now you know the step. First term will become d square, second term will become dd prime, third term will become d prime square. Okay, then replace d is equal to m, d prime is equal to 1. Then you got your auxiliary equation. This is quadratic equation, so you got two roots. Two roots are same. So if two roots are same, then that extra multiplication will come, x square, x cube, those multiplications. So first function you write as it is, and 2 multiply here. Second function also you 2 multiply here. Both the roots are same, so to show that you just multiply x here. That's all done. Okay, now example where this example is big example because I have taken biquadratic. Biquadratic means power is 4. Okay, so simply you can see here, I know this term will become d power 4, this term will become d cube and d prime, here d and d prime cube, and here d prime power 4. So again d you replace with m and d prime you replace with 1, and then your biquadratic equation. Now see, there is if biquadratic equation is like this, the way it is on my screen, then this equation is simple equation, you can find out roots. But usually you don't expect in gate exam that biquadratic equations they will give to solve, because biquadratic equation is very tough to solve, right? Nothing tough, I am saying that how much time we get in gate exam, that much time we cannot spend to solve biquadratic equations in gate exam to find out 4 roots, 5 roots, 6 roots. No, even though if you know the process, you skip the question if this kind of situation is coming. Okay, so now here finding root can be tricky, but such situations will not occur in gate aerospace exam. But if it is coming and you are enough fast, you have good practice on mathematics, just go ahead, find out root, because once roots are there in your hand, then quickly substitute in functions, got the answer. But how to solve? Because roots are the main game in our PDE currently in this chapter. So see what I did. 2 m cube is there now, so I split like separate, minus m cube, and here plus m square and minus m square I added extra in the equation from my side. Anyway, this will get cancelled, so equation is balanced. And this 2m I also split like plus 1 plus m and m. So see what I did. This 2m square m cube I split like m cube plus m cube, here 2m also m plus m, and extra m square term I introduced in the equation from my side. So overall here I have split, here I have split, here I have added extra term, correct? Now then you start taking from the first two terms you take m cube common, from here and here you take m cube common, from here you take m square common, from here you take m common, and from here you take plus 1 common. So you can see after taking lot of things common, in same pattern you got m minus 1, m minus 1, m minus 1, m minus 1. Now you take throughout m minus 1 common, then you will become cubic, but it is not like a so heavy cubic because you have 4 terms. So from here you take m square common, from here you take minus 1 common, so minus 1 again you take minus 1 out, so we got here. Now here m square minus 1, that you split as x m plus 1, m minus 1. So finally m minus 1 3 terms, so we got m minus 1 whole cube like this, and here you got m plus 1. So because of m plus 1 we got m is equal to minus 1 as one root, and m minus 1 cube we got 3 roots plus 1 plus 1 plus 1. So you can clearly see because of minus 1 I'm writing only one function, f1y final complementary function, f1y plus bracket minus 1x, right? That is m1 because of m1. Then from here onwards 1 1 1. So f2y plus x because of 1, f3 f3y plus x, f4 here it should be f4 because f2, so f3 for f4, right? This should be f2, this should be f3, this should be f4. Y plus x, y plus x, y plus x. But here you multiply x because second root is equal to first root. Here you multiply again x, so x square you multiply because third root is equal to second root. Done. Note, similar pattern should be followed if roots are imaginary. For example, suppose you are solving any differential equation and you got four roots like this: minus 1 I plus root 2, 1 plus I by root 2, minus 1 minus I by root 2, plus 1 minus I by root 2. They all are separate numbers. So in that case, simple. Uh, this guy you substitute here in the left side of x, that means coefficient of x. This guy you substitute here, all the roots are separate. Nothing to worry if the roots are complex, nothing to worry. Okay, and pi you skip. Then we have non-homogeneous linear PDEs. Non-homogeneous linear PDEs. Just now what we saw, that was linear homogeneous. How do you know it is homogeneous? So in case of homogeneous, you can check the order. All the terms will be having same order. How do you know? You can see here. You can see here power 4, power 4, power 4, power 4. So order is same for all the terms. So it is homogeneous. Then we have a topic non-homogeneous, but we are not going to cover that for GATE aerospace exam. Okay. So in non-homogeneous linear PDEs also we have to find out complementary function and partial differential equation, but this entire thing we are not going to skip. So here when you cover this topic in your university exam, people will teach you Monge's method also, but for GATE aerospace exam you don't need, so just go for fifth lecture further.